Quick thing before we get into it. I am Javad. I used to administer the TOEFL and GRE exams in person, and for a while, I was ETS Global's official preferred associate in Iran. So this isn't theory for me. I sat across from thousands of people taking this test, and the listening section was where I watched good students lose the most points. Almost always because they hadn't listened enough beforehand. That's what this is about. Just the actual lectures and announcements that this test is actually built on. The way they actually sound with a quick note on the useful language afterwards. Put it on in the car, put it on doing the dishes. Your ear catches more than you think it does. Today, we're going to talk about a physics class lecture. Let's cook. I have a question for you. There's a bowling ball and a coffee mug. They're both sitting still on the same table. Which one's harder to get moving? You just said the bowling ball. So did every physics student for the last 300 years. And you're about to find out you're right. For the wrong reason. The real answer breaks a rule that fooled the entire world for 2,000 years. And today's lecture, word for word, the way it actually sounds in the university lecture hall, and exactly the way it shows up on your TOEFL listening section. Welcome to AJAX. Real TOEFL lectures follow a pattern almost every time. A claim, a wrong historical answer, the one fix that corrects it, then examples that keeps getting bigger until the professor lands on one closing sentence. Once your ear catches that shape, you stop chasing every word because you already know roughly where the lecture is headed. Keep that shape in mind. Here's the lecture. Okay, so that bowling ball and mug question, everyone says the ball, and that's not wrong to be honest, but it's not because the ball is trying harder to stay still. It's not trying at all. Neither one is. That's actually the whole idea for today. You see, this whole idea is wrapped up in one dumb question, believe it or not, about kitchen objects. For 2,000 years, people believed one thing about motion, and it was wrong. Aristotle said motion needs a constant push. Stop pushing, it stops. For example, a cart stops rolling when the horse stops pulling. Makes sense, right? It matched everything people could see with their own eyes. Nobody questioned it for a very long time. And this is not because people were careless. It was because it somehow felt true. And that's worth remembering. The things that felt true are often the hardest ones to question. The first real crack came from a man named Galileo. Early 1600s in Italy. He rolled balls down ramps and he noticed something strange. Let a ball roll down one ramp, then up in a second ramp. No matter the angle of the second ramp, the ball always tries to reach the same height it started at. Make the second ramp flatter, the ball rolls further, because it needs more distance to reach that same height. So Galileo asked one question. What if the second ramp is completely flat? Forever flat. His answer, the ball keeps rolling, right? He could never actually test that. There is no such thing as a perfectly flat surface that goes on forever. But the logic held up anyway. And that idea became the seed for Newton's law. So, what changed? One thing. Friction. Nobody before could isolate it because nobody had ever seen a word without it. Take a hockey puck. Push it across a wood floor, it slides a foot. Then stops. Same push, same puck. Now on ice, it slides much further. Now, take the ice away too. Take away every bit of resistance. Put that same puck in the vacuum of a space. No friction, no air pushing back. It doesn't slow down, not slowly, not eventually, just keeps going forever. And forever is the key word there. Not because something is pushing it forward, because nothing is stopping it at the moment. And here's the part that surprises most people. You think motion needs an explanation. It doesn't. Motion is an object's default state. Whatever an object is already doing, whether moving or sitting still, that's its natural state. Only a change needs an outside cause. Newton didn't figure this out because he was smarter than Aristotle or Galileo. He figured it out because he trusted the math more than his own eyes. Now you accept that one idea, rest and motion are basically the same thing, unless something interferes. A lot of strange things stop being strange then. Why does your body jerks forward when a car stops suddenly? Your body was already moving. It wants to keep moving, straight ahead, until the seatbelt provides the outside force that stops you. The car isn't throwing you anywhere. You're just continuing to do what you were already doing. Same reason the tablecloth tricks work. You see that cloth? That they pull the cloth fast enough and the plates barely register anything happen. Because inertia holds them almost exactly where they started. And here's the biggest example we've ever built. The Voyager probe, launched in the 70s, still moving right now as if we're talking. Further from Earth than anything else we've ever sent. Nobody has been pushing them forward for 50 years. They got one last push from the Jupiter's gravity, and after that, there was nothing left to slow them down. So they just kept going. Not because of what's pushing them, because of what isn't, in fact. And that's the whole idea. Nothing changes its own motion without a cause from outside it. That's the entire law in one sentence. Everything else is just that same idea, showing up in bigger and bigger situations. From a hockey rink to a spacecraft that's been flying since before most of us even were born. All right, now I'm going to give you 5 words and phrases from the lecture that shows up constantly in academic English, particularly TOEFL exam. The first is to isolate. It means to separate one factor out so you can study it alone, you see? Like it said, Aristotle had no way to isolate friction from motion because he never observed the word without it. The next word is default state, which means what happens automatically with no outside cause needed. For example, motion is an object's default state, not something that requires ongoing explanation. The third word is outside cause, or also known as external force. A push or pull coming from beyond the object itself. The exact phrase used across physics passages. Only an external force can change an object's velocity. Fourth is to register. Typically we say to register something, which means to notice or respond to it. The plates barely register that anything happened because inertia holds them in place. Finally, to hold up. Usually we say to hold up an idea, or an idea holds up, or somehow like this. It means to remain valid under scrutiny. Galileo logic held up even though he never got to test it directly. Use these in your speaking, not the physics content itself. The shape of the phrases. Examiners aren't scoring you on inertia, of course. They're scoring you on whether you can use language like it's naturally under time pressure about a topic you didn't choose. That's the law of inertia, not the textbook definition, the way it actually sounds when someone explains it to you. Go back and re-listen to today's lecture once. With eyes closed, no transcription. See how much of it you can catch the second time. That gap between the first listen and the second is exactly what this test is measuring. Good luck.